That's a pretty histrionic title. Really what I'm going to talk about is why the focus on teams is not really the most effective thing that we can do when we're trying to improve our service delivery. How many of you were with me on this stage last year? Okay, it looks like about a third of you maybe. Great. You'll see this is something of a continuation because last year I talked about how many of the things that I had done in order to work with one team, in order to develop them into a team that used by themselves agile and lean thinking for all of their decision making. They were a very, very highly functional team, and any one of whom could work as an agile coach. They really understood these concepts. What do you do when you've done that? You know you've got a great team that's functioning very, very well together, and yet, for other reasons, your stakeholders are still not happy with your levels of predictability or your delivery times. And you can explain all of that because of the system in which you work. One of the great thinkers in systems thinking, Donella Meadows, describes a system as an interconnected set of elements that work together to perform some function. And systems thinkers say that the purpose of a system or the function of a system is what it does. Not what it's supposed to do, not what it was designed to do, not what you want it to do, but what it does. So I'm convinced that the function or the purpose of many IT departments, the systems that comprise many IT departments in large organizations, is to overpromise, underdeliver, and then really, really efficiently shift blame. But one of the things I like about systems thinking is you can model a system using only two elements, stocks and flows. This is a really quick introduction to systems thinking and systems modeling. So in this case, we're going to start with two stocks, and a stock is anything measurable. It can be cash, knowledge, product, parts, customer satisfaction. And in this case, we're going to look at an example in which your stocks are the number of eggs and the number of chickens. And these stocks are related to each other through two flows. One we'll call laying, one called hatching. More chickens, there's more laying. More chickens, more laying, more eggs. More eggs, more chickens because of hatching. And anytime you have a change in a stock that causes a change in itself, as you do here, we call that a feedback loop. In this case, this is a reinforcing loop because it's constantly reinforcing the same behaviors in both stocks. Reinforcing loops are inherently unstable. Left to run its course, this system would produce an infinite number of chickens and an infinite number of eggs. So it's unsustainable. But luckily, there's another stock in this system. Fatal road crossings, and it has a relationship to the number of chickens as well. More chickens cross roads, more chickens who cross roads, the more chickens get hit by cars. Now, whether your farm is in the countryside in the Netherlands or next to a Polish highway will determine where this system balances out the number of chickens. But this is something that we call a balancing loop, and its function is to stabilize the system. So now this whole system, depending on how people drive, is going to stabilize at a certain number of chickens. How can we use something so simple to understand our complicated worlds? Here's a model that I use to explain some things that were going on in some of the places that I've been. I start with a stock I call crises. In large organizations, we know all about crises. There's more of them or there's less of them, but when they happen, we've got two possible responses. Heroics or improvement of the system. But unfortunately, the feedback loop here has a delay. System improvements are slow to address current crises. So we tend to use heroics, and we say, well, when we're done, when this crisis is passed, we'll work on improving the system. But there are other stocks involved here too, such as heroics usually causes more expediting, more people working late, people calling on other teams to produce faster, people calling in SLAs and shorter terms and such, and so they produce more crises for other people throughout the organization. And this, you can see, is a reinforcing loop, encouraging more crises and more heroics. And there's another down here, which is more expediting, means less time and attention to system improvements, which also creates a larger reinforcing loop, encouraging heroics. And there's yet another reinforcing loop that I've identified here. Heroics tends to lead to rewards. You fix the crisis, you get a pat on the back. You might even get promoted. You get a sense of accomplishment. If enough people get promoted because of their heroics, you end up with a whole middle management layer who only knows one solution to these sort of crises that happen. So sometimes you find yourself in these systems in which the systemic issues keep the team from being able to function. The team is just a component of this system, and if the system is not functioning the way that stakeholders would want it to function, what can the team do? Well, the first thing is to know when you're in such a situation. And I had a fabulous training, it's called Enterprise Service Planning, with Alexei Zhigulov, that was fabulous. And one of the things that he said, which comprises it very neatly, is that when any of these three things happen, when you've got fat tail lead time distributions, and I'll illustrate all of these, long average lead times relative to your deadlines or milestones, or high volatility in staff liquidity, you have a situation in which is inherently unpredictable. There's too many things that can go too wrong for you to use predictions, and what you need rather is an active leadership to change the system. So if you make a histogram of your lead times, so you probably end up with something like this. This is a very common shape in our industry. It's called a Weibull distribution. In this case, this is a fat tail Weibull distribution, which is a Weibull distribution that has a k-value of less than 1. And what that means is a lot of people look at average lead time. I talked about this last year. But as you can see, there's a 50% chance that things will happen slightly sooner than average, and a 50% chance that things will happen much, much later than average. And that's what the fat tail means. It means when things go wrong, they go very, very wrong. And also, when you have that kind of average of, in this case, 24 days, if you're delivering batches of product every 30 days, 24 days in is way too late to find out that you've got a problem. So that's the problem when you have long average lead times relative to the promises that you're making or the expectations that people have of you. And in terms of staff liquidity, you can think of staff liquidity like market liquidity. If you want to sell your house and there are a lot of buyers for the house, you've got a highly liquid housing market. If you want to sell your house and there's nobody who wants to buy your house, you've got a very non-liquid housing market, very low liquidity in that market. Staff liquidity refers to when something needs to be done, is there someone to do it? Someone qualified and able to do it or not? So take, for example, the way it looks is you're at a daily stand-up meeting and the whole team's standing around the board, and everyone agrees on what the highest priority item is to do next, but nobody wants to commit to taking it because that particular item includes working on or touching some legacy code which has no tests in there, and Agnieszka is the only one who's been around here long enough to touch that without breaking anything, and she's on holiday. That's a low staff liquidity situation. When those things happen unpredictably, like, for example, you have one whole iteration in which you're doing a lot of work that all touches that legacy code, and Agnieszka is on her summer holidays, what do? Or even if she's here, does she do all of the work by herself? So these are the situations that can cause systemic problems that are outside of the team. But where do you fix them? So much of our work in organizations focuses on the individuals, on hiring, training, motivating, having one-on-one meetings with individuals, but individuals themselves have very little impact on the system just through their behavior. Replacing a mediocre programmer with a rock star programmer does not dramatically or even significantly impact the functioning of an entire end-to-end delivery system in large organizations. I refer to that as like single-digit improvement. Teams can change the way they work to work much more efficiently and much more effectively, and they can have significantly more impact, but the real high-value impact when you have these sorts of issues comes from your top management and executive leadership. How many top managers, VPs, CEOs do we have? Not many. And so for that reason, I'm going to be talking about what you can do if you're not in a position of power, and yet you've run into this roadblock where your team is functioning fabulously, but people are still dissatisfied because of things that are outside of your direct control. And I refer to that as hacking the system, or if you prefer something a little bit less violent, optimizing the behavior of the team for the constraints imposed on it by the system. So I'm going to break these issues down, things that cause delays or volatility, into 3 different components. Those that happen upstream before the work gets to your team, those that happen while you're in process, and those that happen downstream after you finish the work but it still is not delivered to the customer. So in terms of upstream sources of delays, one common one that I've seen in a number of teams is when the process of defining work takes a long time because there are a lot of stakeholders and they don't have enough information to do their jobs properly. And so I've seen teams that they're working on a project, they're very busy, there's a lot of work that has to be done, but they keep running out of work to do. And they have to go back to their product owner and the stakeholder group and beg for more requirements. And in this case, this team solved the problem. What they found is that they were delivering about 5 items a week. But when they started really begging for more work, it took about a week to get a batch of about 10 new items for them to work on. So what I suggested that they do is they just set a replenishment point. So when they have 5 items left in their backlog, that's when they start begging for more work. And in this way, they don't have those downtimes. Another thing you can do is clearly define your acceptance criteria, because something else that happens is sometimes these upstream stakeholders don't know the best way in which to give you the requirements that you need. And so they overwork the solutions, or they perform too much solutionizing. If you can give them a really clear set based on your experience of what boxes they need to tick in order to give you the requirements, it helps them to do their job more efficiently and keep that work flowing into your part of the system. You can visualize failure demand. John Seddon defines failure demand as work that you do that creates more work for yourself. Things like poor quality code that causes bugs that you have to fix later, or poor requirements definition, or poor market understanding that requires you to have to go back and rework things that you've done before, improve features because when they got into the market they weren't optimized for the user's actual needs. If you visualize these things, and if a team member sees something on the board and they say that's failure demand, that's something we could have done better, that's something we should have done right the first time, and you visualize them and you save those and use that data, you can find patterns. And if in those patterns you identify that 50% of your team's time is spent doing things that could be prevented, with more user research, you might be able to demonstrate that the cost of a bit more user research is significantly less than the 50% of the development cost. And in that way influence changes in the upstream part of the system. You could use demand shaping policies. It's been famously brought up that when you've got an expedite lane, it's always used. And so a common solution to this is if you only have so many real live site emergencies, for example, if on a bad quarter you've got 2 live site emergencies, you might make a policy that says you're only allowed to expedite 2 items a quarter. You can't be stuffing our expedite lane full of whatever it is that management wants this week because it impacts our system negatively. So that's referred to as demand shaping. And then from the strategic position, from the high-level position, the CEOs, the CTOs, what they can do is to conduct strategy reviews, which they probably do already. But the way these things usually work is a bunch of very senior people get together and they've got 50 or 100 things they want, but their IT department is only able to consistently deliver, say, 18 to 22 projects a year. And so through using ROI and politics and bullying and whatever it takes, they manage to get their requests down to, say, 25. And they feel really proud of themselves and they're sure that this year will be better than any other year before. But trying to shove 25 products through a system that can only actually process 20 of them is just as painful to the system as trying to shove 50 or 100 through. So if these strategy reviews are aimed at trying to balance capacity and demand and being realistic about what the system is capable of delivering, that's a way that you can avoid putting extra overburdening on the system. So that's the downstream part. But what about when the work is actually in your hands and you're doing the best job you can, but there's something outside of your team that's impacting your ability to deliver the kind of lead times you'd like to? Some of the things you can do is start tracking blockers. A lot of people will block a task when it's blocked, and when it's done, they take the blocker off and they throw it in the trash. This is really valuable data. If you write on a blocker ticket exactly what the blocker is, what caused it, who repaired it, how long it took, and then collect those things, or just put them on a board when you're done with them, you can use affinity mapping to identify patterns of blockers. In this case, people may be complaining most vocally about the testing server when it's down, but clearly even a small improvement to the way in which you coordinate with your API team would have a much larger impact on your lead times. This is one that I like. If this is a situation that I once saw in which there was a third-party team, a shared component service team servicing a component, and every time a team touched that component, because they were using it in ways that it was not designed to be used, they had to request some changes to it, either bugs or feature changes. And it happened every single time. There was a feature that hit this component, they'd have to make a request to that team. Well, that team worked in 2-week sprints. So that means that on average, you're always making a request in the middle of a sprint, and you have to wait to get into the next sprint, and then it's 3 weeks before you get the change delivered, which adds 3 weeks to every single task that touches that component. But since this is a known thing that happens every time, they could request of this team. They could say, we're going to start work on this next week. We know we're going to find a bug. We know we're going to have a request. Can we put in a placeholder ticket, which you can prioritize in your next sprint planning? So it's in there, and when we find the issue during your sprint, we can just fill in the details then. That takes a 3-week lead time and shortens it down to 1, because on average, you're defining it in the middle of the sprint and getting it in a week instead of in 3 weeks. To address the staff liquidity issue, you can do cross-training. You can have pair programming, you can have people training each other. One of the things that one of my teams did that was really effective is every person on the team agreed at least once a week to take the task on the board for which they were barely qualified. A task that involved a skill they didn't have in a part of the workflow that they weren't used to working in, or part of the code that they weren't familiar with, and then doing what it took in order to deliver it in a high quality way. Whether that means getting support from somebody else to do it, doing research, or what have you. And over time, you end up with a team full of T-shaped people who have a very, very high staff liquidity, because anybody can do practically anything that comes up, and the work keeps flowing. Something that I did very effectively is I identified some of these teams, these other outside third-party or shared services teams that we relied on a lot, and rather than just being a ticket in their system, when a ticket was closed, I would look and see who did the work. And I would give them a phone call or send them an email, thanking them and explaining why it was important. Because so many of these teams are just trying to close tickets. They don't understand the value that they're offering to the business as a whole. So when you can say, because you were able to close that in this amount of time, we were able to deliver this feature, it generated this much value, and this is the kind of feedback we're getting from customers, you build relationships with the entire value stream for these people. You give them visibility, and you also make friends. So the next time you raise a ticket in their system, you can also send them an email and say, you know, remember that thing we talked about? I just raised another ticket, and it's a similar issue. You're more likely to get prioritized higher. You can also request SLAs if you don't already have them. They can be based on historic data. This gives you more predictability, and it also may change the way that people prioritize your tickets. You can put a WIP limit on blocked work. So you can say, this is the total amount of blocked work that we're going to allow on our system at any one time. We're not going to let this pile up. That both has the value of raising awareness and creating a sense of dissatisfaction rather than just accepting that these things happen, getting people to work on it. It also keeps you from piling up work behind blocked work, solving the problem rather than ignoring it. If your problem is that you often have people being pulled off of the development process to help out upstream with customer discovery or estimations, for example, you can visualize that part of the work and incorporate it into the entire system so you can see exactly what's going on. And you can put WIP limits on that upstream work that work for you as well, so that you can then control the entire workflow. And this is another area where good customer acceptance criteria can help. If you find that a lot of your delays in process are caused by poor requirements, you can look for patterns and then change your acceptance criteria to make sure that your stakeholders are providing you really the information that you need to do your job without that added friction. Another thing that you can't necessarily do, but more senior management might suggest, is to have more frequent replenishment. So for example, in that example with the Scrum team that was doing mostly bug fixing, mostly small stuff in 2-week sprints, if they were working in 1-week sprints, they'd be cutting 1 week off of everybody's lead time in the entire organization. So things that senior management can do, these are things that a team could never do, but can be very powerful, are things like dealing with staff liquidity by having a floating talent pool. At any given time, some teams will be overburdened and some won't. So if instead you have a group of specialists and maybe some generalists who are able to go from team to team where they're needed, you can keep work flowing much more smoothly. You might even do this with some of the specialists in your shared component teams, have them available to work with teams directly. Other ways of enabling shared services to work better are embedding them in teams. You could break up a shared service group and put specialists into the teams that need them the most. You can co-locate them, but this is, again, the kind of things that can only be done by very senior management. You can have more customer-centric metrics so that your shared services teams are making their prioritization decisions based on the actual value to the customers rather than just number of tickets closed per period. And then in terms of downstream, when you're done, the features are finished, but they're not live in customers' hands yet, there's also a lot of things that you can do to improve the delivery times. The ops teams, usually downstream of your delivery teams, have a lot of quality control processes in place in order to guarantee system uptime. If you learn those processes and incorporate those kinds of tests and quality requirements into your own practices and show them how you're doing it, you can earn trust in order to facilitate quicker deployments of your work. Another thing you can do is, in many places you've got to request a delivery window to deliver to production in advance. In one organization I was in, all deliveries had to be, all deployments had to be made, requested 7 days before they were made. And so one of the things I started doing was just requesting a 1-day deployment window every single day, first thing when I came into the office. And I could do that because we had developed trust with the ops teams. So eventually people just get used to signing off my requests every single day. And more frequent frequent deploys means less time sitting in ready to deploy queues, which means shorter overall lead time. And that allows us to deploy often. Now, obviously, from a senior management point of view, from an executive point of view, probably the most impactful thing you could do is invest in the kind of training and reorganization that is necessary to develop an efficient DevOps culture. This is something that, of course, we could talk about for hours or days. All of these ideas you could delve much more deeply into. I'm trying to give you an idea of how many options are available on different levels, but this is probably the single most impactful thing that an organization can do. And another thing that they might consider is reconsidering metrics. Usually, ops teams are measured on things like system stability and uptime, and development teams are measured on things like throughput. Imagine how much it would change behavior if those were reversed, for example. Imagine if the development team's responsibility was to make sure that when they said something was ready to deploy, it was 100% safe. And if the ops teams were measured on how fast they could take deployable code and get it to clients, how that would change behavior. Maybe in some places dramatically for the better, maybe in some places very dangerously for the worst. But changing the rules of the game is one of those big levers for changing the way a system works. So what I wanted to illustrate here, because I ran through a lot of things really fast, is the number of things that I was just able to think of off the top of my head and things that I have tried. There are many, many more things that you can do once you get to that point where our team is fabulous, our team is running well. It's the system, it's everybody else. And getting out of that position of blame into an empowering, enabling position in which you can start to actually work better within the system, even if you don't have the power to change the system itself. If you just take some of these things, like if you look at your old lead time distribution, and you say, well, if we improved our coordination with this key shared service, it would cut about a week off of 20% of our tickets. Then you do it. and you've got a new lead time distribution with a shorter average lead time and a little bit more predictability. If you went to deploying daily instead of batching up 2 weeks worth of work, you could cut an average of 1 week off of all of your lead times across the board. So do that and make things a little bit more stable, a little bit more predictable. If on-demand replenishment, instead of having a backlog where things sat in a queue before they got started, just amassing lead time, if instead you were able to develop the kind of relationship with your upstream product owner such that they could pull in work as needed and you could have a shorter queue, then that would have cut time off of all of your lead times across the board. You do that, and just by doing small little enhancements to the way in which you work within your organization, the way you work within the system, you just eat away at this until you no longer have a fat tail Weeble distribution. You've got a reasonably predictable process without necessarily making any large-scale systemic changes. So I hope, I want to leave you with this as well. I know lots of us in this industry are readers. These are the books that most inspired me during the course of the last 6 to 9 months when I was also thinking about these issues and developing this talk. I can highly recommend all of them, especially starting with Thinking in Systems. That's a brilliant introduction to systems thinking. So I hope that, I know that all of these ideas won't work for all organizations, but my hope is that you've seen at least 1 or 2 or 3 initiatives that might get you over a hump, that might get you started in finding new and better ways to work within your organization and to take some personal responsibility and some team responsibility for things that previously might have appeared to be fundamentally unchangeable systemic issues. Thank you very much for your attention.